NASA STEM Engagement and Educator Professional Development Collaborative logo. Welcome to NASA STEM EPDC Quick Bits Science and Engineering Practices. NASA STEM Engagement and Educator Professional Development Collaborative provides NASA resources and STEM strategies for STEM engagement. In this series, we intend to reach educators, parents, and caregivers to quickly explain a specific big idea in STEM. We will introduce a NASA example of how this idea is applied in the real world, and finally, we will demonstrate step-by-step how to lead this activity at home or in the classroom with your students. You might invite your students to watch with you at that time. We invite you to join us as we learn more from our specialists. Let's get started.
3, 2, 1, take off. I am Monica Uribe, NASA Education Specialist at Armstrong Flight Research Center in California. The title of this activity is Shape Your Flight. This Quick Bits big idea is to present science and engineering practices, obtaining, evaluating, and communicating information. In this activity, the student will engage in the following practices. Obtaining, evaluating, and communicating information in grades 5 through 8 builds on previous grade experience and progresses to assess the accuracy of ideas and methods. Read and understand complex, grade-appropriate text and/or other reliable means to summarize and obtain scientific and technical ideas, and describe how they are supported by evidence. Carefully read scientific texts adapted for use in the classroom to determine main ideas and/or obtain useful scientific and/or technical information to describe patterns and/or evidence about the world, or natural and designed worlds. Combine the information in the written text with the content in the corresponding tables, diagrams, and/or graphs to support participation in other scientific and/or engineering practices to clarify the information and conclusions. Obtain and combine information from books and/or other reliable means to explain phenomena or solutions to a design problem. Evaluate data, hypotheses, and/or conclusions or scientific and technical text accordingly to competing information or evidence. And communicating scientific and/or technical information orally and/or in written formats, including bibliographic references, tables, diagrams, and graphs. Aeronaut X is one of NASA's next-gen STEM programs focusing on research and technology advancements in aeronautics, which have served as small steps and have been an important part of many significant NASA accomplishments known as giant leaps. Aeronaut X focuses on the latest in aeronautics and the principles of sound, especially on research to create a new generation of experimental aircraft. We will focus on the activity called Shape Your Flight. The objectives of this activity are to explore geometry and its relationship to the design of airplanes, to explain to students the forces of flight and how important they are to understanding how NASA uses these principles when designing an airplane. In this activity, students will build a paper airplane, calculate the area of the wings using triangular diagrams, and calculate the accuracy of the flight using the Pythagorean Theorem, to evaluate the information in the data table and interpret the results. But how it is that an airplane can fly from one place to another with precision? Which of the paper airplanes tests will be the best? My hypothesis is that the calculation of the flight path helps the airplane to have a more precise route and travel the smallest area possible. Even with today's technology, NASA uses the same aeronautical principles used by the Wright brothers in 1903. And to understand these principles, it is important to understand the four forces of flight, which are drag, thrust, lift, and weight, which must be balanced for an airplane to maintain a stable flight. Likewise, it is important to understand Bernoulli's principle, which states that the pressure in a fluid decreases when its speed increases, and Newton's first and third laws. Newton's first law states that an object at rest remains at rest, or if it is in motion, it remains in motion until a net external force acts on it. Here you can see a ball filled with candy. The astronaut will drop it and let it float throughout this module of the International Space Station. On Earth, the ball will eventually fall to the ground due to gravity, but in space and with microgravity having an impact on the ball, it will continue on its way for a long time. The air in this module also generates friction, which is the force that acts on the ball and helps it gradually slow down. A Newton's third law, which establishes an action and reaction force, exists if object A exerts a force on object B. Then object B must exert a force of equal magnitude on object A. Can you see the difference? One of the main parts of the airplane that helps it fly are its wings. Aeronautics is the study of the science of flight. Aeronautics is very important at NASA. The first A in NASA stands for aeronautics. NASA's aeronautical engineers must understand 4 basic areas to design an airplane. Aerodynamics, which helps engineers design the geometry shape of the airplane, including the wings. Propulsion, which will help engineers determine the type of engine and the appropriate amount of force that an airplane needs. The materials and structure, and the stability and control that engineers will study to control speed, direction, and altitude. The geometry of the wings is one of the main factors affecting the lift of the airplane. The airflow, which moves faster over the top than on the bottom, results in a lower air pressure that is located at the top of the wing, which makes the wing and the airplane attached to it fly. To have a better understanding of certain aviation-related problems, it is necessary to use mathematical ideas from trigonometry. A right triangle is a 3-sided geometric figure with an angle equal to 90 degrees, which is called the right angle. This is where the right triangle gets its name. The side opposite this right angle is called the hypotenuse, which we define with the letter H. It is the longest side of the sides of the triangle. Hypotenuse comes from 2 Greek words, hypo, which means under, and teinen, which means to stretch, since this is the longest side. For this activity, it is recommended to use the Pythagorean Theorem, which states that in every right triangle, the length of the hypotenuse is equal to the square root of the sum of the area of the squares of the respective lengths of the legs or sides. Or, in every right triangle, the square of the hypotenuse is equal to the sum of the squares of the legs. Remember that scientists and engineers must be able to clearly communicate the ideas and methods they generate. Critiquing and communicating ideas individually and in our groups is a critical professional activity. The communication of information and ideas can be achieved in multiple ways, such as using tables, diagrams, graphs, models, and equations, as well as orally in writing and throughout lengthy discussions. Scientists and engineers employ multiple sources to obtain information that is used to evaluate the merit and validity of claims, methods, and designs. To analyze whether the hypothesis of the airplane's trajectory was correct, I invite you to perform the activity Shape Your Flight. You will need the guide for the Shape Your Flight activity. The materials to be used are paper to create the plane, adhesive tape to mark the takeoff point, a ruler, a pencil, measuring tape, the activity sheet, and a calculator. Remember that the objectives are to build a paper airplane and calculate the area of the triangular wings and the accuracy of the flight. To build your paper airplane, I suggest to follow the instructions on page 5 of this activity. Once you have your paper airplane, for part 1, you will draw 2 right triangles on each of the wings of the airplane, assigning variables A, B, and C. A will represent the base of the triangle, B the height, and C the hypotenuse. Then you will take measurements of the sides of the triangles in centimeters and you will calculate the area of the triangles, recording your results on the worksheet part 1. For part 2 of the activity, you will have to fly your airplane from the same height. The height of your shoulder is recommended as accurately as possible and from the same takeoff point. There are 2 parts for this activity. In part 1, You will measure the size of the triangle for each of the wings and calculate the area of the wings in centimeters. For part 2, you will reflect the test of your airplane where you will classify the triangle, calculate the size C, or the hypotenuse, applying the Pythagorean Theorem, and you will have the opportunity to calculate the perimeter and the area of the flight triangle of your airplane. The distance between the landing line or side A, which must be perpendicular to the flight line to create a right triangle, then records the distance between the takeoff point and the perpendicular point that the flight line crosses or where the right angle is created. This will be side B. Which test was the most accurate? Which has the smallest area? Why is geometry important when designing an aircraft and determining the accuracy of the flight path? How does the design of the size of the shape of the wings affect the flight path? You can extend this activity by creating your own airplane designs and using different materials. When evaluating and analyzing the results of the 3 flight tests, particularly for this test, the test that yielded the smallest measurements was test 1. When analyzing the measurements of the flight triangle, it is reiterated that the test that was most accurate when following the flight line was test 1, with a flight triangle area of 2.1 square meters. I hope you enjoyed this activity. Don't forget to fill out your worksheets.
Thanks for watching this NASA STEM EPDC Quick Bit. Don't forget to check out the description below for more information and links. www.txstate-epdc.net. Logos for the Texas State University LBJ Institute for STEM Education and Research, NASA STEM Engagement and Educator Professional Development Collaborative, and NASA Partner. The material contained in this document is based upon work supported by a National Aeronautics and Space Administration (NASA) grant or cooperative agreement. Any opinions, findings, conclusions, or recommendations expressed in this material are those of the author and do not necessarily reflect the views of NASA. Images and footage courtesy of NASA. Images and footage used under licenses from Shutterstock.com and Envato.